So can anyone please tell me advantages of series circuit?
Sure.
Hmm.
A single switch is enough to operate all the components together. We require less wiring in series circuit.
Yes, these are advantages. And what are the advantages of parallel?
Sir, if one of the components is out of order, then other components still keep on working, and the other one is since all the components have equal voltage of the power supply, lamps will glow brightly.
Okay, so I would like to say you one technique. Then you can make your life easier. You do not need to memorize all the advantages, all the disadvantages. Just you remember or memorize advantages of series circuit and advantages of parallel circuit. Okay,
Okay, sir.
then other things will come to your mind automatically. If you know advantages of series circuit, you can make disadvantages of parallel circuit, right?
Yes, sir.
And if you know advantages of parallel circuit, then you can make disadvantages of series circuit. Is it clear?
Yes, sir.
So you try to practice it, huh? Then it will be very much easier for you to make and apply. Now the last part of this topic, that is potential divider circuit. Already we have this idea that in series circuit we got the EMF is shared among the components. Same idea we will use here. Potential divider rule, it works for series circuit. Is it clear? Hello?
Yes, sir.
Potential divider rule, it works for series circuit, and the way we got series circuit, the EMF of the power supply shared, we will get two formula now to get them calculated how much they will share, and what will be the formula where we have to put which value. Then it will be easier for you to get the exact value. If the two components they are identical, then they will share definitely equally. But if they are not identical, then we are applying this two formula. Is it clear,
Yes,
Monica,
sir.
Adrita?
Can you repeat it again?
Yeah, so Monica, could you please read it? What?
Potential
Hmm.
divider. The potential divider rule is used to solve circuits. The main concept of this voltage divider rule is the voltage is divided between two or more resistors or any components, that is, lamp, fan, LDR, heater, etc., which are connected in series in direct proportion to the resistance. We use the following formula to find the PD across a resistance.
Okay, so these two formula you are getting, one is V1 equals R1 by R1 plus R2 multiplied V, where V is the source voltage. R1 and R2 are two resistors connected in series. V1 is the voltage shared across R1, and V2 is the voltage shared across R2. Now what you will do, you will write the heading. In your copy you write the heading potential divider. This heading, after writing this heading, you just write this two formula. Potential divider, you write this two formula and write this description where V is the source voltage and R1 R2 are the two resistors connected in series. V1 is the voltage shared across R1, V2 is the voltage shared across R2. So I am underlining what you are supposed to write. This one you write, this heading, then you write this formula, and write this formula, then this writings you should write. Monica,
Yes, sir.
so here you see uh, you got disconnected. You read till here, and after we have two formula, and here is the you know the explanation. What is what? V is the source voltage. R1, R2 are two resistors connected in series. V1 is the voltage shared across R1 and V2 is the voltage shared across R2. What is underlined here, please write them, okay?
Okay, sir.
Quickly.
Sir, done.
Okay, done. Now we will use this formula and this technique in the circuit given below. You draw the circuit, you write the example, then you draw this circuit. We have two resistors here. One is 2000 ohm, another one is 10,000 ohm. This circuit you draw. So we are considering R1 as 10,000 ohm. This one is R1 and this one is R2. So in your drawing you label this one also. R1 is 10,000 ohm and R2 is 2000 ohm. And here the voltmeter reading will be V1. Across R1 you are getting V1, and if there is another voltmeter here we connect, if you are connecting another voltmeter like this, V, so it will be V2. So V1 it comes 5 volt, and V2 will be how much? 1 volt, right?
Yes, sir.
Because we have here 6 volts, so if R1 is sharing 5 volt, then R2 will be 1 volt. And you can also use the formula to get the calculation. You already got here V1 equals R1 by R1 plus R2. Then you got values, and V1 equals 5 volt. Similarly, for V2, if you write the values, it will come 1 volt. You can have a check. So, are you done with drawing and writing?
Yes.
Yes, sir.
So, have you applied this formula for V2
Yes, sir.
and you got 1 volt?
Yes.
Have you got 1 volt? Yeah.
Yes, sir.
Similarly, we can do many questions like this. Here we have 2000, 10,000. Maybe other places there will be 5,000, 6,000, this way. So any value we are getting, we can calculate it using this formula. Okay. So done. Potential divider is done. Any questions here in potential divider?
No, sir.
Adrita,
Yes, sir.
hello. Have you understood?
Yes, sir.
Okay. Then Mahi Khan, Monica.
Yes, sir. Understood.
Yeah. Now we are going to the worksheet. How much we understood and how much we learned, that one we will apply in the worksheet. Okay, let's go there.
Sir,
Mhm.
I think I have a question on the calculation.
Sure. Which calculation?
The last one we did on the formula V1 is equal to V R1 by R2.
Yeah, this one.
Yes, sir.
Yeah, what question you have?
How do we get fivefold?
Here you see we have here 6 volt, huh? Then 10,000 plus 2,000, how much? Hello?
Sir, 12,000.
12. Yeah, Monica, how much you got? 10,000 plus 2,000? 12,000,
12,000.
right? 12,000, right?
Yes, sir.
Then 10,000 by 12,000, if you get the ratio, it comes 5 by 6, right? If you simplify it, it comes 5 by 6, isn't it?
Okay.
So 6 6 can be cut, right? Then we have
Yes,
5
sir.
left. Have you understood now?
Yes, sir.
Okay.
And
Same way.
sir, for the V2, we also have to multiply it by
Yeah,
6.
yeah, yeah.
What is
Both.
the 0 for at the end?
Yeah, here we have 2000. For R2, we will have 2000. Other things are same. Then you calculate, it will come 1 volt. 2000 by 12,000, how much? What is the ratio? 1 by 6, right?
Yes, sir.
Then 6 cut, 1 is left.
But sir, in the diagram, why do we have 2 volts given?
Where is 2 volt?
One is 6 volts and the other one is 0 volt.
Okay. This one actually written plus, right?
Yes, sir.
And here we have 0 volt. That means we have here potential difference of 6 volt. Okay.
Okay. Okay.
That means we are focusing in the potential difference. Here is 0, then here is 6. Then what is the potential difference between these 2 points? That is 6 volt. Is it clear?
Yes, sir.
Okay. Then any other questions? Any more questions here?
No, sir.
Okay, thank you. Now we are going to worksheet. Are you seeing the question?
Yes,
Yes,
sir.
sir.
Okay, so you read it, huh? Adrita, hello Adrita,
Yes, sir.
can you please read it?
Yes, sir. Number one, meter, three resistors, power supply. Which arrangement of the resistors gives the greatest immediate field?
Yes, greater amateur reading. Greater amateur reading when we will get. If the current is more, right?
Yes, sir.
And when you will get more current? If the resistance is least, right?
Yes, sir.
Yes, sir.
So we have to now calculate where we get the least resistance. There will be most current and greatest ammeter reading. Okay,
Yes, sir.
Okay, sir.
so find it, everyone. Try to get it. Calculate using the formula you got. You got two formula, one for parallel, another for series, right? To calculate combined resistance. So which one is easiest to calculate resistance? D, right?
Yes, sir. D.
D is the easiest one to calculate resistance because you simply have to add them, right? Because they
Yes, sir.
they all are in series. So 2 ohms, 4 ohms, 4 ohms, it will be 10 ohms, right?
Yes, sir.
So here we write 10 ohms. Then we have here C. The second easier. Why we are saying second easier? Because these two resistors are identical, 4 ohms and 4 ohms. If two identical resistors they are connected in parallel, then their combined resistance will be half of their single resistance. So here it will be 2 ohms. 2 ohms. If you use the formula, then it will also be coming same way. Then 2 ohms plus 2 ohms combined resistance will be how much? 4 ohms, right?
4 ohms. Yes, sir.
4 ohms. 4 ohms will be combined resistance. So here we got 10 ohms, here you got 4 ohms. Are you understanding?
Yes, sir. Understood.
Sir, I
Monica,
did not understand the C.
yeah, I need your response. Then I can uh, do it easily for you. So what is the formula for calculating parallel combination? This part is parallel, right? What is the formula of parallel? 1 by Rp equals,
Sir, 1 by
1 by R plus 1 by 2.
it was like 1 by Rp equals 1 by R1
R1
plus
plus 1 by
1 by
R2.
R2, isn't it? This was
Yes,
the
sir.
Yes, sir.
formula for parallel. Now you put the values for 1 by R1, that means 0.1 by 4, right?
Yes,
Hello?
sir.
So 1 by 4 means 0.25 plus 0.25. Then it comes 0.5, right?
Yes, sir.
Then 0.5, it comes for 1 by Rp. So for Rp, it will be 1 by 0.5. That means you have to reverse it, isn't it?
Yes, sir.
So Rp will be equal to 1 by 0.5. That's coming 2, right? That's coming from calculation, isn't it? Hello?
Yes, sir.
That's coming from the calculation, but we also teach you some trick to make your calculation easier. You should know some tricks, right?
Yes, sir.
Yes, sir.
So what is the trick? Trick is, if two resistors are identical and they are in parallel, then their combined resistance will be half of single resistor. So it's coming 2 ohms, right? We calculated, we got the proof, but before calculation I told you this, right? Isn't it?
Yes, sir.
So when you are getting two identical resistor with the same resistance, then their parallel combined resistance will be half of their single resistance. I think you can remember it, right?
Yes, sir.
So 2 ohms and another 2 ohms. Now the whole arrangement here, 4 ohm, 4 ohm, we have here 2 ohms, and these 2 ohms is connected with another resistor 2 ohm in series. So series connection we have uh, added, right? R1
Yes.
plus R2, isn't it?
Yes, sir.
So we have here 2 ohms and 2 ohms. These two are in series. So our total resistance will be 4 ohms. Is it clear?
Yes, sir.
Now another easy technique for A. Just now we applied that two parallel resistors, they are connected together. Their combination will be 2 ohms, right? You see 4 ohm, 4 ohm, they are in
Yes, sir.
parallel. So it will be 2 ohms, right? Only these two, lower two. And now these 2 ohms and the upper 2 ohms, they are again parallel. So here will be 1 ohm, right? Isn't it?
Yes, sir.
So the total resistance of this circuit is 1 ohm. It is simply we are getting it, but we can also use the calculation, the same formula, the formula we used. We can use the same formula to calculate it. It will come. Uh, okay. So the total resistance of this circuit is 1 ohm. Have you understood it? Hello?
Yes.
Yes, sir.
Maimuna is saying yes. Then Adrita, are you saying yes?
Sir.
Hello?
Yes, sir. Hello.
Yeah. Then Mahikan, have you understood this?
Yes, sir.
Then Monica, have you understood this?
Yes, sir.
So just now we calculated it, this part. We had 4 ohms, 4 ohms. We calculated 2 ohms. Similarly, these two, if you calculate, it will also come 2 ohms. Now, these 2 ohms and another 2 ohms, they are working together. Then it will be coming combined 1 ohm. So for this circuit, A, the resistance is 1 ohm only. Okay. Combined resistance is 1 ohm here. So for the whole circuit it's 1 ohm. Is it clear? Hello?
Yes, sir.
Now this one we calculate again. A parallel combination. This one we have to do calculation, no shortcut way. 2 1 by Rp equals 1 by 2 plus 1 by 4. So 1 by 2 means 0.5 and 1 by 4 means 0.25. Then it comes
0.75.
0.75. Then Rp comes, you have to reverse it, right? 1 by 0.75. Then what it comes?
So 3 by 4.
3 by 4 or 4 by 3. We have here reversed it, right? 1 by 0.75. Look, you
Yes,
have
sir.
here
4 by
1 by Rp equals 0.75. So Rp will be 1 by 0.75.
3.75.
Yeah, then it will be 4 by 3, isn't it? 4
Yes,
by
sir.
3 means what?
Right.
1.33.
Yes, sir.
Okay, then 1.33 we got. Then your RS, what will be RS? RS will be 4 ohm plus 1.33, right?
Yes, sir. It's
Then
5.33.
it will be 5.33. So where we are getting least resistance, where we are getting least resistance, where?
A.
A. That will be greatest ammeter reading. Got it?
Okay,
Now,
sir.
for this question, you have anything that you did not understand? Any idea is here you did not understand? Monica,
Yes, sir.
have you understood this question?
Yes, sir.
Okay.
So, sir, the
So,
answer is A, right?
yes, A, I gave the circle, A. You see, A, I gave the circle. So we are done with one of the MCQs. We have uh, more MCQs. Here, if you go back, go down, lots of MCQs are there. So till Thursday, we need you to try this MCQ part. Okay, this is only current electricity topic. Current electricity. We have another worksheet that is on DC circuits. Okay, so I want you to print out both the worksheets,
Okay, sir.
and you, after giving the printout, you try topic 19 MCQ part. Okay,
Okay, sir.
as much as possible you try. Some of you can do, some of you can't do. So you try, and next class we will discuss them, inshallah. Okay.
Okay, sir.
So thank you so much, everyone. Huh? We are
Thank you,
done
sir.
till here today. Allah Hafiz. Best of luck,
Lovely,
eh,
sir.
everyone.